Hey, what's up guys? It's your boy Jarrod Rananan.
And Iravel Oreta. Our topic for today is all about array deletion. Deletion means removing an element from the array. Suppose this is a linear array A. From this array, we delete an element. If we want to delete the element from last position, then it's very simple. We can delete the last element directly. If we want to delete 9, then just remove the element from the list. But if we want to delete an element from k position of the array, where k is less than upper bound, then what happens? Suppose this is another array, and this is the k position. Means, here you want to delete this element, so what we do for this case? We need to shift all the elements from k plus 1, upper bound, one position leave, or in other words, we can say we need to shift all the elements from k plus 1 to upper bound from current position to previous lower index. For example, we shift 2 here, then we shift 9 to here, and the deletion is completed. Next, we see the algorithm. A is a linear array that has n elements. We delete the elements at k position. And this is the k position for this example. K is 2. Our first task is to store the deleted element in a variable. So in step 1, write x to a of k. This step is optional. If you want to use the deleted element further in your program, then you can use this step. Otherwise, we can skip this step. Next, we assign the value of k plus 1 to variable I. Step 2, that is I equal to k plus 1. For this example, I is equal to 3. Step 3, I'm going to write while I is less than equal to upper bound. If condition is true, then receive a position element to its previous location, that is ai minus 1 equal to a of I. For this example, a of 3 will be shifted to up to then increment the value of 1, that is I equal to 1 plus 1. In this example, I will check again this condition. If this condition is true, then we execute these two statements again. Here I equal to 4 and upper bound is also 4, so this condition is true. A of 3 will shifted on A of 2. Then we shift A of 4 to A of 3 and then increment the value of I by 1. So now I is equal to 5. On upper bound is 4. So this condition is false and come out of this loop after deleting an element. Total number of elements will be decremented by 1. So we set n equal to n minus 1 and then step 5x. And that's it.
Next, we can see how we can implement this using Turbo C++. Here are the first task is to declare an array that hold the input numbers. For that, I'm going to declare here int array and the size of array is 100. Then, we declare other variables also that we use in our program, that is num, I, and then position. Next, I'm going to ask the user how many elements they want to print. Print enter number of elements. We read the input number using scanf function. Scanf %d, and here we referred ampersand number. Ask the user to enter elements printf to read the elements. We use for loop. For I is equal to 0, I less than num, then I plus plus. Inside the curly braces, I'm going to write scanf %d, and here we refer ampersand array I. Next, we print the input array to the screen. For that, I'm going to write here input array is, then for I is equal to 0, I less than num, then I plus plus. Inside the curly braces, next, write printf %d, give had a space array I. Next, I'm going to ask you to enter the position of the element that the user want to delete. Printf enter the position of the element to be deleted. Next, I'm going to write scanf %d in the ampersand position. Next, we shift all the elements from position +1 upper bound one position left for that, I'm going to write here I equal to position plus 1, and then I'm going to write while I is less than equal to num minus 1, since we stored the array element from 0 position, so upper bound will be number of element minus 1. That's why we write here I less than equal to num minus 1 inside the curly braces. I am going to write here array of I minus 1 equal to array of I, and then increment of value of I by 1, that is I++. After deleting an element, total number of element will be decrement by 1. For that, I'm going to write here num minus minus. Next, we print the after the deletion. For that, I'm going to write here printf after deleting array is, then for I is equal to 0, I less than num, then I++ inside the curly braces. Printf %d add space array I.
Let's check the output. Compile and run. As you can see, here it asks for the number of elements. I'm going to enter 5. Enter element. I'm going to enter 6, 7, 9, 1, and then 4. Input array. Enter 3. Here, we store the array element from 0 position. So this is the first position, second position, and this is third position. So 1 will be deleted. Let's check, and how we see here 1 is deleted, and that's it. Thank you for watching.